Hello class, let's go through the notes on parallel lines and transversals. So theorem 3.1 is the corresponding angles theorem. And it says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Okay, just a quick note, we know that congruent angles have the same measure in degrees. And the symbol for congruent would look like this. It looks like a little equal sign with a tilde on top. Okay, so just make sure you write that down. And let's write down the examples of corresponding angles in this picture. Okay, now we know from before that corresponding angles are in the same relative position. So for example, look at angle 1. You see how angle 1 is in the upper left-hand corner in these set of angles. So the other angle that's in the upper left-hand corner is angle 5. Therefore, we know that angle 1 is congruent to angle 5. They are corresponding. What other angles are corresponding? Let's look at angle 2. Let's go in a numerical order. 2 is in the upper right, and so is 6. So angle 2 is congruent to angle 6. Angle 3 in the lower left-hand corner is congruent to angle 7. They are both corresponding. So angle 3 is congruent to angle 7. And then finally, angle 4 is in the lower right, in the same position as angle 8 in the lower right. These are corresponding angles, which means that angle 4 is congruent to angle 8. Okay, now let's look at how we would use an algebra example to solve for x. So let's say that these two lines are parallel, and I'm going to put the parallel marks here to indicate that they're parallel. I see that these parallel lines are cut by a transversal. This is a line that crosses the two parallel lines. And notice that angle 3x plus 5 is in the same relative position as angle 65. Do you see how they're both in the upper right-hand corner? Well, that means, according to the corresponding angles theorem, that 3x plus 5 is equal to 65. So I can set up an algebraic equation to model that situation. And now I could solve for x by subtracting 5 on both sides. I get 3x equals 60. And I could divide by 3 on both sides to solve for x to get that x is equal to 20. So using the corresponding angles theorem, I can solve and figure out that x equals 20. Okay? Now let's look at another example down here. In this diagram, I know that this angle here is 120. And if I think to myself, well, where is this angle? This angle is in the upper left-hand corner in this cluster of angles. So if I can figure out another angle in the upper left-hand corner, I know that angle will be 120 degrees as well because they will be corresponding angles. So let's see. It looks like angle 5 is in the same relative position. Therefore, angle 5 is also equal to 120 degrees. Now, let's move on to the next theorem. The next theorem is the alternate interior angles theorem. This says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Let's write down all the examples of alternate interior. So we know from before that angle 3 and angle 6 are both inside the parallel lines, and they're on alternate sides of the transversal. Therefore, we can say that angle 3 is congruent to angle 6. That means their measures will be equal. But there's another pair of alternate interior angles. Do you see how angle 4 and angle 5 are also in between parallel lines on alternating sides of the transversal. So we can say that angle 4 is congruent to angle 5. Now, how does this help us problem solve? Well, if we look at this example here, and we notice that 128 and 2x are both inside parallel lines and on alternate sides of the transversal, that means they are alternate interior angles. That means they are equal in measure. And in math, I can then say that 2x is equal to 128. And to solve for x, I could simply divide by 2 on both sides of the equation to get that x equals 64. Looking now at the alternate exterior angles theorem, says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So let's write down the alternate exterior angles. So these angles have to be outside of the parallel lines and on alternate sides of the transversal. So here, angle 2 is going to be congruent to angle 7 because they are alternate exterior. Similarly, angle 1 is going to be congruent to angle 8 because they are alternate exterior. Again, they are on alternate sides of the transversal and they are outside or exterior to the parallel lines. Now, using that example here, we can say, what other angle is alternate exterior to 120? Well, I need another angle outside the parallel lines, and I need that angle to be on the other side of the transversal. So the only angle that meets that criteria is angle 8, right? It's outside the parallel lines, and it's on the alternate side of the transversal. So I know that angle 8 is equal to 120 degrees. Moving on to our last theorem, it's the consecutive interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Now we know what supplementary means. Supplementary means those two angles add to 180 degrees. So here, instead of setting the angles equal to each other, we're going to have to add them to 180 degrees. Let's write down the examples. Consecutive means in a row. Interior means inside the parallel lines. So for example, angle 4 and angle 6 are going to be consecutive interior. So angle 4 plus angle 6 equals 180 degrees. I'm doing that because I know that they are supplementary. Similarly, angle 3 plus angle 5 are consecutive interior. So I know that they add to 180 degrees. Okay, now let's look at an algebraic example. If I can say that 72 degrees and 7x plus 24 are on the same side of these parallel lines and they're inside the parallel lines in a row, I know that they are consecutive interior. So I know that they both add to 180. So I can say that 72 plus 7x plus 24 equals 180. And now I can solve for x by combining like terms. I know that 72 plus 24 is going to give me 96. So I get 96 plus 7x equals 180. I can subtract 96 from both sides of the equation. That's going to give me that 7x equals, 84, right? Because if I borrow here, that's 84. And if I divide by 7, I'm going to get that x equals 12. So again, I use the properties of consecutive interior angles to solve for x. Okay, now let's look at some of these more interesting problems. Well, here if I want to solve for x, I don't necessarily have anything obvious, but I need to use the clues in the picture. So I can say that 65 and this mystery angle 5, which isn't really 5 degrees, it's just a mystery angle, they must be the exact same measure. How do I know? I know that because 65 and 5 are in the same relative position. They're on the lower left in the cluster of angles. So I know that this angle this angle 5 must be 65 degrees. So I'm just going to put a 65 degrees in there, okay? And then notice what you see here. Isn't it true that 65 degrees plus 11x minus 17, these are on a straight line? And we know that straight lines add to 180 degrees. These form what is called a linear pair. So I can say that 65 plus 11x minus 17 equals 180. So I use some deductive work here to figure out the equation. And once I have an equation, I can then solve for x. So what I'd like you to do is we'll pause the video, and I'd like you as a challenge to try to finish solving for x here, and then see what you can figure out. Use your problem solving skills to try your best at solving these problems, okay? Now, when you solve these problems, you're solving for the missing angle. So here you want to solve for angle 1, and you want to solve for x. Here you're going to solve for angle 1, 2, and 3. And here you're going to try your best to solve for angle 4 and x. So I will see you in the next video where I give my detailed solutions to these problems. But I'd like you to just see if you can try it on your own first, and then we'll check our answers.